I took this problem straight from the 2017 AP Physics C exam because I thought it was cool.
Dang, College Board is gonna come after you now.
This is not the entire problem. I just took a piece of it because the real problem had a bunch of parts like A, B, C, D, E, F, G. So I stopped it at part C. Anyway, let me read the problem. So, an Atwood's machine consists of two blocks connected by a light string that passes over a frictionless pulley of negligible mass, as shown in the figure below. The masses of the two blocks M1 and M2 can be varied. M2 is always greater than M1. So this is our Atwood's machine with the two blocks. Part A. On the dots below, which represent the blocks, draw and label the forces, not components, that act on the blocks. Each force must be represented by a distinct arrow starting on and pointing away from the appropriate dot. The relative lengths of the arrows should show the relative magnitudes of the forces. Okay, so we're trying to draw a free body diagram. So let's look at M1. What forces are acting on M1?
Force of tension up and the force of gravity down.
Excellent. Are they going to be equal length? Is one going to be bigger than?
That depends on the masses of each block.
Very great answer. So it says M2 is always greater than M1.
Tension should be bigger than.
Yeah. So for M1, it's going to be going up, right? Because M2 is heavier. So M2 goes down, M1 goes up. Since M1 is going up, there's a net force upward. So tension has to be greater. The upward force has to be greater. I'll draw it like that. I'll call it T. And I'll make the mg a little shorter. This is capital M1G. All right, because this is moving upward, you should have a longer upward force because the net force is upward. What about for M2? What are the forces on that?
So force of gravity down, which is bigger than the force of tension, just up.
Exactly, because it's moving downward, so there's going to be a net force downward. Is the tension for M1 the same for the M2 block?
It should be.
Yes, so the good thing is that the string is light and it's over a frictionless pulley. So since it's the same string, the tension is going to be the same because we're assuming that the string is not going to stretch. So the tension is going to be the same. I'm going to copy paste it. If you drew the tension longer like this, or you drew it shorter on the AP exam in 2017, you would lose points.
Those dastardly College Board people.
Yes, very unfortunate. But yeah, since we have M2 is moving downward, I'm going to have a longer downward force. So I'm going to draw it like this. So that's capital M2G. Part B, it says using the forces in your diagrams above, write an equation applying Newton's second law to each block and use these two equations to derive the magnitude of the acceleration of the blocks and show that it is given by the equation here. A equals m2 minus m1 divided by the quantity m1 plus m2, all times g. Let's define our coordinate system. Everything's vertical in this problem, like the blocks are moving up and down, so we just need to talk about the y direction. So I'm going to make up positive. Up is going to be the positive y direction.
Before you move on, I think the most important step here is to pick a direction. M2 needs to drop 2 then, so that upward doesn't mean positive for M2, it means positive for M1, and then downwards means positive for M2. But you need it to match because acceleration is basically going in one direction.
I see what you're saying. Very good points. This is where me and the physics textbooks disagree. So,
Dang, he's going off the script.
yes. So M1, that block, is going to accelerate upward. We'll call that acceleration the acceleration in the y direction for block 1. We'll call that A. And since block M2 is accelerating downward, I'm going to say that the acceleration in the y direction for 2 It's gonna be the same, but opposite. It's gonna be negative a, because downward is negative in my coordinate system. So, what some physics textbooks do is they have two different coordinate systems. What they do is they say, okay, for the first block, up is positive, and for the second block, down is positive. So both of them have the same acceleration a. But I think it's better to just do one coordinate system for the whole thing. Even though now the sign is different, I think that's fine. But either way, you're gonna get the correct answer. Does anyone agree with my way, or do you guys think the no one likes it?
You're becoming college bored right now, and I don't appreciate it.
Oh my gosh.
I think dubious guy has a point.
Well, let's see how the equations are gonna be set up with this coordinate system now. I think it'll be fine, you'll see. So we're trying to find acceleration. Let's look at the forces on block one and the forces on block two. So let's look at block one first. So the sum of the forces in the y direction on block one equals m1 times acceleration in the y direction for block one. So looking at our free body diagram for block one, the sum of the forces is tension minus m1g. And this equals m1 times ay1. And I just said that that equals a. Block one is moving upward. So this is just a. So we don't know tension and we don't know a. So I need to look at the sum of the forces in the y direction for block two. So for block two, the sum of the forces, same thing, tension minus m2g. And this equals m2 times negative a, because ay2, because of my coordinate system, is negative a, since block two is accelerating downward. So this becomes negative m2a. If I did it physics textbook style, I would have made downward positive for M2, and I would have done M2G minus tension equals positive M2A. But you see how that's like the same thing as this? They do down minus up.
I see it. I see it.
Yeah, so I always do up minus down because I made up positive. And I just put a negative on the acceleration. But they do down minus up and make the acceleration positive. So I don't really like that way. We now have two equations with two unknowns, tension and acceleration. So let's do substitution. So I'm going to solve for tension here and substitute it in here in the first equation. So tension, I can just add m2g to both sides. So you get m2g minus m2a. And now I'm going to substitute that into the first equation. So tension is m2g minus m2a right here, minus m1g equals m1a. So we're trying to find a. We're trying to prove that it equals this. So I'm going to get all the terms with a on one side and solve for a. So I'm going to add m2a to both sides. So you get m2g minus m1g equals m1a plus m2a. All right, so to solve for a, I'm going to factor the a out, and also on the left-hand side, I can factor g. So I get m2 minus m1 times g equals m1 plus m2 times a. And to solve for a, I just divide both sides by m1 plus m2. So I get a equals m2 minus m1 over m1 plus m2 all times g.
I mean, it's an answer if I ever saw one.
Yup. Exact same thing as what they wanted. All right. Even though I did a different coordinate system where up is positive for everything. Okay. So that's part B. And let's do part C now. There's more parts, like I said, but I stopped it at C. So the magnitude of the acceleration A was measured for different values of m1 and m2, and the data are shown below. Indicate below which quantities should be graphed to yield a straight line whose slope could be used to calculate a numerical value for the acceleration due to gravity g. Okay, so they give us a bunch of data. They changed m1, they changed m2, and they found the acceleration for each m1 and m2. So you can graph all of this, but we need to figure out how are we going to graph it? What's going to be the vertical axis and what's going to be the horizontal axis? And how can we make it so that the graph is a straight line with a slope that's related to g? So does anyone have any ideas? We have a relationship with acceleration and g right here that we just derived. And what's the equation of a line? Let's start with that. Let's go to the basics.
Y equals mx plus b.
Yeah, so we want y equals mx plus b. I don't think we're really going to have a plus b because I don't see a plus anything here. It just looks like something times something. So really we're looking at y equals mx for this problem. So it looks like y, like the vertical axis, it'll be a. And x will be this ratio here, m2 minus m1 divided by the quantity m1 plus m2. That'll be our x. And then the slope will be g, right? That'll be our m. So if I make the vertical axis a and I make the horizontal axis m2 minus m1 divided by m1 plus m2, then you'll get a line whose slope is g. We'll get a numerical estimation for g because this is data. So you're going to have a bunch of points and you're going to find the best fit line. All right.
Actual data experimentation
Yep.
on this math channel?
Yep. Believe it. It's the first
That's
time.
heresy.
One question I have for you guys is what if someone swapped these two? Is it okay if I make the vertical axis m2 minus m1 over m1 plus m2 and I make the vertical axis a? Will the slope of that give me something with g? I mean, let's look at this. If this is y and this is x, I can divide both sides by g. This will be our m.
Well, you get 1 over g as the slope.
Yeah, so that's fine. You'll get the reciprocal of what you want. So that can also be a valid answer too, because it says can be used to calculate g. So you can use 1 over g to find g. But
At least in this case, just to give you more correct answers, not fewer.
this is the most straightforward way of doing it, but you can also do it switched. Okay, cool. Well, that's all I got for today. Make sure to like and subscribe, guys, and comment any questions you have. And I'll see you guys in the next video.
Take care. Bye.
Adios.